What is blockchain? For many of us, the usage of blockchain is thought to be only confined to cryptocurrency. A blockchain is essentially a type of DLT or distributed ledger technology. It is an unalterable ledger with a digitally coded signature called a hash, duplicated and distributed across the entire cyberspace. Blockchain technology was first outlined in 1991 by Stuart Haber and W. Scott Stornetta, two researchers who wanted to implement a system where document timestamps could not be tampered with. Their goal is to allow digital information to be recorded and distributed, but not edited. Blockchain.com is a private company currently led by CEO Peter Smith, one of its three founders. The first blockchain database and Bitcoin white paper were created by Satoshi Nakamoto, a name believed to be a pseudonym. Despite many attempts to uncover his identity, so far none successful. Although several names have been proposed but none proven beyond doubt to be Satoshi Nakamoto. A block represents the present which contain information about its past and future. For example, a Bitcoin block contains information about the sender, receiver and the number of Bitcoins to be transferred. The completed block is a permanent record in uniformly sized blocks of past and the current new transactions. Each block duplicates all the data from previous blocks. Any type of transaction can be stored in blocks on a blockchain, for example, copyright ownership to a song, issuing a university degree or who owns a particular piece of land and so on. To be added to the blockchain, each block must contain the answer to a complex mathematical problem. This problem is created using an irreversible crypto system. The node that solves this problem is given the right to place the next block on the chain and publish it. This complex math problem, called the proof of work POW, is coming up with a 64-digit hexadecimal number, called a hash, that is less than or equal to the target hash. Hexadecimal or hex is a base 16 system used to simplify how binary is represented. Binary is a method of representing numbers that has 2 as its base and uses only the digits 0 and 1. Each successive digit represents a power of 2. The authenticity of a blockchain network is verified by a set of rules which uses a combination of the proof of work consensus algorithm known the Nakamoto consensus. Proof of work and proof of stake or POS are two common consensus. As for any business transaction, the final goal is monetary gain. Bitcoin miners, for example, receive Bitcoin as a reward for completing blocks of verified transactions, which are added to the blockchain. Miners earn Bitcoin by finding POW and creating blocks. The transaction fees for each block is approximately 1.5 Bitcoin equivalent in value for each block. More on cryptocurrency in our next video. The application of blockchain is expanding widely in our increasingly digitalized world due to numerous advantages compared to traditional means. Due to the fact that it cannot be erased or replaced once any data is written, tampering is not possible. Whereas traditional databases are prone to manipulation or third-party hacks, blockchain not only provides secure transactions, it reduces compliance costs, speed up data transfer processing, increases transparency, the traceability of data and delivers cost savings with much efficiency. Any central certifying authority or third-party intermediary like bank or government as such are entirely left out of the equation. Hence it is expected to become the preferred mode of business transactions such as transfer of money, property, contracts to name just a few. There are 4 main types of blockchain networks: public blockchains, private blockchains, consortium blockchains and hybrid blockchains. Public blockchains target the general public as end users, but private blockchains are geared toward invitation-only users and their networks. The largest global company embracing blockchain is the IBM. It has invested over $200 million in research and development integrating Hyperledgers into their systems. Hyperledger is a global enterprise offering the necessary open-source blockchain infrastructure across various types of industries. Another is the global US e-commerce giant Amazon, with their blockchain infrastructure focusing on developing smart contracts, thereby delivering additional value to their customers. Not to be outdone, Google too has been adding blockchain into services wherever it realized the potential, such as using Google Cloud Platform to build and manage the Ethereum Blockchain Explorer with Cloud. The best blockchain network hosts are 1. Blockchain on Amazon Web Services or AWS. 2. SAP Cloud Platform Blockchain as a Service or BaaS. 3. Microsoft Blockchain on Azure. And 4. IBM Blockchain Platform. Although blockchain is not immune to hacking, it is difficult since a hacker would need control of more than half of all the computers in the same distributed ledger. Any 51% of attacks necessitates the attacker being able to gain control of more than 50% of the hashing power. In the event of any such an attempt, they can be quickly removed by the network's community since the rules of removal are also coded into the blockchain. Thus far, Bitcoin blockchain has not suffered a 51% attack because it has an active hashing power which is tough to manipulate. Other than for monetary gain, the intention for hackers can be to bring down a currency or the network too, thus the term Goldfinger attack. The World Economic Forum foresees that by 2025, 10% of global GDP will utilize the blockchain technology. The impact of this is expected to be as significant as the Internet revolution itself. Statistically, since 2018, no less than 50 new blockchain initiatives are launched every day encompassing every type and level of industry. To focus on just a few, the following are some of the global applications of blockchain technology. 1. Government. Blockchain technology is being used by a number of governments to store public records. For example, the citizens of Finland are granted freely to access to such stored records. The U.S. Department of Homeland Security (DHS) is using a blockchain named Factom as a means of securely encrypting, storing and transmitting the data retrieved from security cameras and other sensors. 2. Digital IDs. Millions of people are currently using Microsoft Authenticator application. It is designing digital IDs within this application that would give users a way to control and manage their digital identities. Credibility of voting results would no longer be an issue since vote tampering is not possible. Once any blockchain data is written, it cannot be erased or replaced. In Switzerland, blockchain is already being used to register residence IDs, proof of residency and online voting. In Europe, blockchain helps to verify accurately trained passengers' personal ID verification in border control checks at multiple points between countries. 3. Digital signature. Digital signature works by a signer electronically signing a document first using the signer's private secured key. A hash is then created matching the signed document using a mathematical algorithm encrypting the data. The current market leader in e-signature technology is DocuSign or Nasdaq, DOCU, with a $55 billion market cap. 4. Financial technology. The blockchain technology is driving a new technology, the financial technology or fintech. It is a new tech that seeks to improve and automate the delivery and the use of financial services. Some industries examples are trading, digital lending and credit, mobile banking and payments. While banks take 24 hours of 5 days working week, blockchain significantly settles this efficiently within a matter of seconds, securely and economically. 5. Real estate. Blockchain helps to store ownership titles on its network, enabling any transparent transfer in the buying and selling of properties such as land, house or vehicles. The U.S. state of Georgia uses it to register land titles, integrating it into the digital records system of the National Agency of Public Registry. 6. Goods tracking. Blockchain technology helps manufacturers, merchants as well as the consumers to track food safety from beginning to end of the production process. One such example is the IBM and Walmart Blockchain Food Safety Alliance in China. 7. Data backup. Compared to the current cloud storage systems, blockchain technology is the preferred mode to back up data due to cloud's inherent infrastructure issues and it being hackable. 8. Healthcare. Blockchain is facilitating authentic data sharing while maintaining confidentiality of medical records. This would resolve the problem arising from inconsistent, incorrect or incomplete patient records and more importantly, hacking. A case in point is the May 12, 2017 National Health Service of England cyber attack, where at least 81 out of its 236 trusts including 595 GP practices across the board were infected by the WannaCry ransomware. 9. Carbon assets. Carbon assets includes the visible assets that generate performance credits as well as invisible assets which are created through time and effort. Such carbon assets can be tracked by a blockchain created by IBM called the Hyperledger Fabric blockchain. This is indeed useful to companies seeking to offset their energy consumption in their endeavor for greener industrial practices. In addition to the above-mentioned industries, it is now difficult to find a sector that has yet to be transformed by blockchain technology. To list some, industries such as tourism, shipping, fishing, insurance, advertising, public utilities, taxation, journalism, music, fine art, oil and gas, transportation industries. The list goes on and is ever growing. There are however other similar DLT other than blockchain such as Hashgraph, IOTA Tangle and R3 Corda. Hashgraph was invented in the mid-2010s by the American computer scientist Lyman Baird. It addresses the distributed ledger differently in that the data is not stored at an individual location or controlled by a single entity. With a superior data structure, Hashgraph is able to solve many of the problems that has been a challenge to blockchain. This is due to it lacking a chain of blocks and its underlying consensus algorithm in the global enterprise. Thus able to achieve similar results faster, fairer, secure and more energy efficient and stable. It can process thousands of transactions per second and does not suffer from any speed difficulty. In short, Hashgraph is also a DLT with similar results to blockchain with the benefits of blockchain but without its limitations. The good news is with this absence of monopoly development, it will undoubtedly be beneficial to all end users.